Okay, so I knew there was a word I wanted to talk to you about. The word I want to talk to you about is transformation. Okay, raise your hand to tell me and the class anywhere that you might have heard or seen the word transformation. Transformation.
Transformers.
The Transformers. What do the Transformers do?
They transform.
You try to tell me without using the word.
Oh, they change.
Transformers change from robots into cars or vehicles in general. Transform is a change. So just like in the movie, it's the same in math. A transformation is a change. In math, we're talking about geometric shapes. And so it's a change in either position. I can be here, or I can be here, or a change in orientation. So if I'm looking at the clock and I'm going to the right, I'm going clockwise. But if I'm going to the left, I'm going counterclockwise. That's orientation, okay? A change in shape. Change in shape. Change the shape. I got to think about that one. And a change in size, kind of like your of your eye. It's little. It's probably big right now because it's a little dark in here. But if I were to turn on the lights, it would go like this. A change in the size is called the dilation. So we're going to talk about these different kinds of transformation. So transformation is the overall big word that describes all of the changes. The first change we're going to talk about is a slide. A slide. Okay. So we're going to take a little doggy. Woof, woof. We're calling Franklin. Hi, Franklin. All right. And this is the pre-image. Pre is before. Okay. So here is Franklin. He's facing to the door. His tail is up. And it looks like he just literally slid up the page. Would you agree? Yes. Size didn't change. His location changed, though. He slid up the page. So his shape stayed the same. His size stayed the same. His position is different. Orientation, he's facing to the door. He didn't flip. So that has the same orientation. Okay? That is one type of a transformation. It's a slide. And we call this a translation. And I like to remember that because slide has LI or SL, slide, and translation has SL. Translation is a slide, like you're ice skating, like a snake. Okay. All right. A flip. Let's take a look at Franklin now. Here's the pre-image. Pre is before. He's facing the door. Okay. Did his shape change? No. He still looks like a woof woof. Okay. Did his size change? Nope. Same size. He's the still little dog. Did his position change? Yes, he's not in the same location. So he's a different position. And how about his orientation? That is different also. He was facing the door and now he's facing the windows. This is a flip. It physically looks like he flipped, right? A flip is called a reflection. And I remember that because flip has an FL and reflection has an FL. So we have a translation, which is a slide, a reflection, which is a flip. Wouldn't that be cool if I did a flip and added that to my little lesson? And then we have a turn. A turn does it have the same shape? Yes, same shape. How about size? Same size. How about orientation? Be careful with this. So here's the thing. He's facing to the door. Now, right now he's facing down, but he did not flip. Like if you picture his head is here and we flipped him, his head is still going in that same direction. We didn't like flip him to totally like over a line of reflection, okay? So he actually has the same orientation, but he is in a different position. Same shape, same size.
So we go by the way he's looking, like forward, backward, right, left?
Yes.
So how is the orientation of the bed?
Because it's like a clock. So like this is going 12, 1, 2, 3. And even if I turned the clock like this, it would 12, 1, 2, 3 would still be in the same order, even though I turned the clock. Okay. Kiefer.
So you said that it's the same orientation because you're still looking at the door?
He's not looking at the door, but it's what I just described to CJ. If you think of it as a clock, 1, 2, 3, okay? If I take the clock and I take it off the wall and physically turn it, it's not in the same location, but it's still going 12, 1, 2, 3. So it's not flipped going 12, 11, 10, 9, okay? All right. Anyone want a shot at what this is called? If a translation is a slide and a reflection is a flip, a rotation, oops. God, it's just so late in the day. It feels like midnight. A rotation is a turn. And so I really like that little stupid little trick, but it seems to work. Okay. Transformation, they all are. They're changing. And then underneath transformation, we have translation, reflection, rotation. Okay. So let's try some. Number one, we've got a little froggy. What do you think? You can't see it on your paper. So look up here. This is a little frog in the water, and he has, Mason, he has a reflection, which is a flip. Reflection is a flip. All right. How about those V-looking things? Angles. Macy. We just took it and literally watch this. I'm going to take it. I'm just going to slide it over here. That is a translation or a slide. Fantastic. How about number 3? Oh, lovey hearts. Lovey hearts, Sarah. This is a turn. We literally, I don't know if I can do this. I'll try. I'm going to trace the heart. And if I turned it, so when you turn, you're turning about a point down here. So you have to kind of move and turn and move and turn. All right. So you're turning about a point down here. So that is a rotation. Is that what you said? Rotation is a turn. How about the double arrows? Makes me think of your calculator. What do you think, Logan? That is a reflection. Your line of reflection would be right in the middle. That is a reflection because it flipped. And there is a line of reflection there. All right. Ooh, check. What do you think about that thing? What do you think about that check, CJ? He says that's a turn. Can you guys see it? It's not a flip, because if it flipped, the check mark would be down here. It's not a slide because it didn't just go over. That actually turned about a point down here, right? It just went, meow. So this is a rotation. And how about this funky thing for number 6, Sophia? Sophie? It just slid. It just slid. This is a translation. Raise your hand if you've seen this stuff before. Oh, some of you have? One paper? Okay, well, you seem good at it. So I was thinking you must have done it before. Okay, so is there a practice on this if you flip the page, or does it go right into our next lesson? It goes right into lesson 1. Okay, so that's my little intro. And so here we go. You don't have to write, you just get to watch as we talk about this. We're going to focus on the translation today. One transformation we're going to talk about is a translation, which is a slide. Each point slides the same distance in the same direction. So when you're looking at a doggy, it's a little easier. When we're looking at a line segment, this means line segment, right? Whoops. Line segment. We're going to translate that line segment 6 units left and 4 units up. So this one's AB. You want to know how I know that? This little thing right here, we say A prime, B prime. That means it is the post image. Okay, so the little slashes mean that happened after. All right, so the red one, line segment AB, we're going to take each point and go 6 units left. 1, 2, 3, 4, 5, 6, and 4 units up. 1, 2, 3, 4. And that's how I got to A prime. I'm going to do the same thing with my other point. 6 units left. 1, 2, 3, 4, 5, 6. 4 units up. 1, 2, 3, 4. And that's how I got to B prime. That creates line segment A prime, B prime. That's how I would say that. Is the shape the same? Yeah. Is the size the same? Is the orientation the same? Left to right. Do I read A, B? Yeah. How about the position? No. So you only have a different position when you're talking about a translation. Everything else maintains, and that's how you do it. Okay. So if we're talking about words, we would say or write 6 units left, 4 units up. If we're talking about doing something in algebraic form, which in this particular unit we call arrow notation, we say that we're going to take a point. Any general point is always xy. Remember that? Okay. And we're going to say algebraically what we're doing. So the x, remember, is going this way. That's your left or right. So what did we do to A, left or right? We went left 6. That is going in the negative direction. So we're going to do x minus 6. And then we went up 4. Up is positive. So we're going to take y and add 4. Does everyone understand how we take the words, show them on the graph, and what that means in algebraic form? I'm going to prove it to you that it works. So this point A was the point 1, 2, 1, 2, 3. This is the point 2, 3. Agreed? This is the point 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So this is negative 4, 7. Everyone okay with that? All right. We're going to take this rule, x minus 6. We're going to take the 2, that's our x, and we're going to subtract 6. That gives us negative 4. Then we're going to take the y, and the rule says to add 4 to the y. So we're going to take the 3, because that's in the y position, and we're going to add 4. And 3 plus 4 is 7. And that's how I get to the point negative 4, 7. Brady and Connor, if you want to go back to 6th grade, you can go. You're discussing it? Would you like to? Oh, okay. So start acting like I'm an almost 8th grader. Good decision making. Now leave him alone. Okay, so look, that's exactly what happened. Negative 4, 7. You with me? So now let's take point B, which is 1, 2, 3, 4, 5, 6, 7, 8, 3. 8, 3. And let's see what point that should become. We're going to take x and subtract 6. So 8 minus 6 gives me 2. Then we're going to take the y, which is 3, and add 4. 3 plus 4 is 7. We should be at the point 2, 7. Let's see if we were. 1, 2, 1, 2, 3, 4, 5, 6, 7. So we can do it physically on the graph move, or we can use the algebraic rule of arrow notation. Okay? So the reason your 8th grade teacher writes it out first is so that you can literally just focus on it without having to worry about copying it down. All right? But now we're going to do one that you're going to have to do. Huh? He already did it? Okay. So let's see. Choose the arrow notation that matches the following translation. Notice you are always going to start with the point XY. That is always going to be the case. Now, how do we show moves 3 units up? Is up and down the X or the Y? Y. And 5 units to the left. So that's the X, right? You always, what? How annoying. Why? Why does this happen? Well, that is just annoying. 3 units down. Why? Why change that? Makes no. All right, I'm going to erase this. I really thought I got this from where this printed from. Okay, 3 units and 5 units right. Okay, I have no idea what difference it makes, but we're going to go with it. We're going to do it. So I'm always do your X first. So this is your X over here, 5 units to the right. Is to the right plus or minus? So that's going to be X plus 5. So this is out and this is out. We're down to 2. Is up, is down positive or negative? Negative. So that's going to be minus 3. Y minus 3 is choice B. How'd you do? Easy peasy? It seems confusing, but it's not too bad. Okay, this one's the same. Write the rule in arrow notation that was used to translate the R to R prime. Arrow notation always begins X comma Y arrow. All right. Now this one's a little bit trickier. I have to figure out what's taking my negative 4. What do I do to negative 4 to get negative 2? What am I doing, Austin? Let's see, plus 2. Is negative 4 plus 2 negative 2? Yes, so we're going to write X plus 2, comma. All right. Now let's do the Y. I'm starting at 6. I want to end up at 10. What am I doing to 6 to get 10? AJ? Adding 4. So y plus 4. This whole thing, arrow notation, the whole thing. Okay? Find the coordinates for point T after applying the same translation. So we're going to use this translation down here. We're going to do -3 plus 2, comma, 5 plus 4. And this gives us the point -1, 9. Is this making sense to everybody? Sarah? Right here? Because it's said to write arrow notation, and arrow notation always starts XY. Here to your choices, you always have to say what you're starting with, and then you say what you do with each of those. Louder.
Like the one on top of that.
On top of this one?
Yeah, that started with the actual letter.
This is not the arrow notation. This is the arrow notation, which is the rule. And then we just took this point and applied the rule to get B prime. Okay? All right. It's details because math is very detail oriented. Oh, this says write the rule in words and in arrow notation that is used to translate trapezoid KLMN. How do I know which is the one I start with? How do I know what I start with, Jack?
You gotta make sure that you're using the one that does not have the primes.
Right. So KLMN is here. All right. So in words, let's talk about what happened to point K. All right. What happened to point K? It went how many?
7.
Down 7. Is that true for every point?
Yes.
N went down 7. 1, 2, 3, 4, 5, 6. M went down 7. L went down 7. Yeah. So all we would say is you have to use the words they use. Let's see. Every point moves. So we're going to write every point moves down 7. This time we didn't go left or right at all. So that's the words part. Cool. Now we have to use arrow notation. When you are giving the arrow notation, that is the algebraic rule. You start with XY. Arrow. What happens to X? Lily. Did X move down? Down isn't an X. X is left and right. So what happened to X? Nothing. It's going to stay X. And then Y went down 7. So this one translates to X comma Y minus 7. So we want to give that example so you see what happens when it doesn't change. This right here is arrow notation. Okay, go ahead and try the next one. How'd you do?
Yay, I got it.
Every point moves. Left 6 and down 2. And then we have to actually do that to, it says graph the image of triangle ABC. Oh, graph the image of triangle ABC. So we're going to take each point. It doesn't matter because you're given a graph if you move it or if you like to write out your points and do that. Either way. So x minus 6. Here's A prime. And we do like straight edges when we're drawing triangles. Okay. You're welcome. It does. Like, it's a lot of explaining, but once you see it, you're like, oh, yeah, duh. Okay, so the next pages are your practice, which is homework. There is a front and a back. I know. There's a front and a back. And thank you for reminding me to